Hello everyone, welcome to Artistic Atom channel. I am Fatima and this is our last session of mass spectrometry topic. In this session, we will discuss empirical formula and molecular formula based questions, especially the questions where the data is given from mass spectrometry. Okay, and here also we will be discussing MCQs and the structured questions, which will help you in understanding the type of questions that may be asked on these topics. So let's get started. Before going ahead and diving deeper into the concept of empirical formula and molecular formula based questions, let us first understand the difference between two. Let us take an example of this fraction in order to understand the meaning of these two formulas. Here I have an example of a fraction 6 upon 12. If I reduce it to the most simplest ratio, I will get the answer as what? 1 upon 2. So this simplest ratio resembles the empirical formula, whereas the exact fraction resembles the molecular formula. Yes, you have understood it right. This means whenever I have atoms and their reduced fraction or the simplest ratio of those atoms in a compound, I will term that formula as what? Empirical formula. Whereas if I have the actual number of atoms present in that particular molecule, I will call that formula as what? Molecular formula. So always remember, empirical formula is the simplest ratio of those atoms in that particular molecule, whereas molecular formula gives you the exact number of atoms present in that particular molecule. Now, since we have understood the meaning of these two formulas, that is empirical formula and molecular formula, let us understand how many types of questions will be asked in exam so that we will be able to use the right method in order to solve the questions. Well, I have analyzed all the papers and I have got this data. Depending upon the given or the data in the question, you can choose any one of these three methods. Okay, other than these three methods, there are no other categories of questions which they can ask because I have analyzed all the papers. So the first type of questions that they can ask is they can provide you with the percentage composition of each and every atom, and then they will ask you to determine the empirical formula or the molecular formula. In such cases, you will always follow the method one. Don't worry, I'll be sharing the respective questions and the respective method in the next slides. Now, the second type of data is this, where they will provide you with empirical formula and the molar mass of that particular compound, and they will ask you to determine the empirical formula. In that case, you will follow method 2. So suppose in your question, if the combustion analysis data is given, okay, so there you will follow method 3. Now, the probability of getting this question in exam is quite less than that of these two. These two questions are frequently asked, whereas this one is not that frequently asked. Okay, but still, this question was asked in some of the papers, so it is necessary for you to know all three methods. Now here I have the question one, where we are expected to follow method one. Let us see how exactly we are supposed to use these steps in order to solve these questions properly. So the question is, an unknown organic molecule J contains only carbon, hydrogen and oxygen and has the following composition by mass. So as you can see, the percentage composition of each and every atom present in that particular molecule is given. So this means this data clearly matches with our first category based question. So there I will follow method 1 in order to solve this question. So as you can see here, based on the mass spectrometry data, I have the molar mass of my molecule as what? 116. So this means the molar mass is given from the mass spectrum data. That's why this question is connected to the mass spectrometry topic. So if you have this particular data given in your question, you will follow method 1, where you will assume the total mass as what? 100 gram. Then you will convert each and every mass. You will write these percentage into their respective masses. That is 62.1 gram of carbon, 10.3 gram of hydrogen, and 27.6 gram of oxygen. After determining their mass, what you will do, you will convert their respective mass into their moles. After moles, you will determine the simplest ratio. Once you have got the simplest ratio, which is nothing but the empirical formula, you will determine the empirical formula mass. Then you will use this formula, that is N is equals to molar mass divided by empirical formula, in order to determine the number of units with which you should multiply to the empirical formula, so that you will end up with the molecular formula. So these are the steps that you will follow, but make sure to check the data. If the data consists of the percentage composition, then only you will follow these steps. Let us go through each and every step in detail. Now, step one, as I told you, assume the total mass as what? 100 grams. So, if you consider that, then each of these atoms will have the same mass as of their percentage composition. So, I will in first step, I will convert their percentage into their masses, and I will write with the unit G, which is nothing but grams. Now, after determining their mass, I will determine their moles. So, how to convert these grams into moles? So, it's simple. Firstly, number of moles. What is the formula for number of moles? It is this. Number of moles is equals to mass of that particular substance divided by the molar mass. So, as I can see, for carbon, the mass of the substance given is as what? 62.1. So I will write the mass divided by the molar mass. What is the molar mass of carbon? It is 12. So if I divide these two values, I will get this answer. So similarly, I will do it for hydrogen. I will do it for oxygen, and I will end up with moles of carbon, hydrogen, and oxygen respectively. Now, after you have determined their moles, the next step is to convert them into their simplest ratio. Now, there is a simple step that you should follow in order to convert these moles into their simplest ratio. The step is, once you have determined all the number of moles, your next step is to check for which of the atom has the smallest number of moles. So if I check these three number of moles, I can see that 1.725 is the lowest number of mole. So I will use this value, and I will divide all three values with that value in order to get the simplest ratio. So once I do that, I will end up with this simplest ratio. And with this simplest ratio, I will write my empirical formula, which is nothing but the simplest ratio of the atoms present in that particular compound. So as you can see here, I have my empirical formula. You can write the respective ratios to the respective atoms. Now, after determining the molecule empirical formula, the next step is to determine the empirical formula mass. So, you know how to calculate the molecular mass of any compound. Just write the molecular formula, do the calculation, and you will end up with the formula mass. Now, after determining the empirical formula mass, the next step is to determine the value of N. So, the formula that I told you to use is this. N is equals to molar mass divided by empirical formula mass. Molar mass of what? Molar mass of your molecular ion, which was given in the question. So you will simply do the calculations, and you will end up with the value of N as what? 2. What is N? N tells you how many times the empirical units are present in one actual molecule. Okay, so once we use this N and multiply it with the empirical formula, this is what the formula we end up with. And this formula is called as what? The molecular formula, which gives the exact number of atoms present in a molecule. So with this, you have understood the first category of question that can be asked based on the mass spectrometry data, where you are expected to determine the molecular formula and the empirical formula. So remember, if you are provided with the percentage composition, you will always follow method 1 in order to solve the question. Now, the next category of question is this, where you are just provided with the molecular empirical formula and the molar mass of that particular substance. So here is the question. Compound Y has the empirical formula CH2O. So here is my empirical formula, which is already given. Now the mass spectrum gives the data of the molecular ion mass. Okay, so the mass of the molecular ion, which is given as what? 180. So I have to follow these simple steps. Okay, this is my method 2, where Using the molecule empirical formula, I will determine the empirical formula mass. And once I have determined the empirical formula mass, I will determine the value of n, which is nothing but the number of units I'm expected to multiply with the empirical formula, so that I end up with the molecular formula. Have you understood this? How you are supposed to do this calculation or selecting the method? It depends upon the data given. So this is the category of question 2. Let us see each step in detail. So the step 1 is to determine the empirical formula mass. So you will write down the empirical formula, you will do the respective calculations and determine the empirical formula mass. Once you have determined the empirical formula mass, you will go and calculate value of n using the formula that I have shared at the beginning. Once you have calculated the value of n, it is nothing but the number or the unit that I should multiply with the empirical formula in order to get the molecular formula. So in step 3, I will directly multiply this value of n with the empirical formula. Then I will end up with what? The molecular formula of the compound. With this, we have completed the second method. Now let us go ahead and understand the method 3. Now in method 3, you will be provided with the combustion analysis data. As you can see in this question, the question given is as follows. An unknown organic compound A contains only carbon, hydrogen and oxygen. When 0.44 gram of carbon compound A is completely burned in excess oxygen, it produces carbon dioxide this much gram and water this much gram. Now, the given data is the molar mass of compound A determined from its mass spectrum is 199 grams per mole. So this is what the mass spectrum data given. So what do we have to determine? We have to determine the empirical formula of compound A as well as the molecular formula of compound A. So I can see that this particular data, that is nothing but the mass of carbon dioxide and mass of water, this data is nothing but called as what? Combustion analysis data. So if this data is given in the question, this exactly matches with the third category, and I will follow method 3 in order to solve this question, where firstly I will determine the carbon from mass of the carbon from carbon dioxide and mass of the hydrogen from water, and after that I will do the take out the difference. That is nothing but this is the mass of the total molecule. So from the total molecule, if I subtract the mass of carbon and hydrogen, I will left with what? The mass of oxygen. After determining their masses, I will determine their number of moles, and from their number of moles I will find out their simple ratio, and that simple ratio is nothing but my what? Empirical formula. And from empirical formula I will determine the empirical formula mass using this formula, where n is nothing but the number of units that I am expected to multiply to the empirical formula, so that I end up with what? Molecular formula. So using this formula, I will calculate n, and finally I will multiply it with the empirical formula and I will get my molecular formula. So this is how you will solve it. Let us see each and every step in detail. So step 1 is to determine the moles of carbon using carbon dioxide data. So firstly, here I can see that 1 mole of carbon dioxide is equivalent to 1 mole of carbon. This means if I have 1 mole of carbon, I will end up with what? 1 mole of carbon dioxide. This means if I calculate the moles of carbon dioxide, it will be exactly equivalent to the moles of carbon. So if I do that calculation, how you will calculate number of moles? Well, we have this formula, that is number of moles is equals to mass divided by molar mass of that compound. So here I have the mass which was given in the question divided by the molar mass. I will end up with the number of moles as follows, which will be exactly equivalent to what? Number of moles of carbon. Similarly, I will calculate moles of hydrogen using water. Now, we know that if I have 2 moles of hydrogen, then only I will get 1 mole of water. As you can see, in water, I require 2 hydrogen in order to form water. So this means 1 mole of water equivalent to what? 2 moles of hydrogen. So whatever is the number of moles of water, I just have to multiply it to it by 2. So I will end up with what? Moles of hydrogen. So moles of water is equals to what? Mass of water divided by the molar mass of water. So mass of water was given in question, which was 0.54, divided by the molar mass of water is nothing but 18. So if I do the calculation, I will get the value as what? 0.03 moles. Now you just have to multiply this 0.03 moles by 2, you will end up with the number of moles of hydrogen. Now, after we have determined that, let us subtract these two masses in order to determine the mass of oxygen. So from the mass of oxygen, we can easily determine the number of moles of oxygen. So if I do the calculation, mass of whole compound is equals to mass of carbon plus mass of hydrogen plus mass of oxygen. So if I have to determine the mass of oxygen, it will be what? Mass of compound minus the mass of carbon and hydrogen. So if I follow this method, so this is what the mass I end up with for oxygen. And from the mass of oxygen, I will do the calculation and determine the number of moles of oxygen by just dividing the mass of oxygen divided by the molar mass of the oxygen. So this is what the moles I have got. Now, after doing this, after getting the moles of all three atoms, I just have to determine the simplest ratio. How to determine the simplest ratio? Whatever is the lowest number of mole, you will divide all three moles by that particular number. So I can see that moles of oxygen is the least. So I will divide all three number of moles of carbon, hydrogen and oxygen respectively by the moles of oxygen. I will end up with these three values as you can see over here. But there is a problem. As we have seen in previous two questions, that when we divide or when we determine the simplest ratio, we were ending up with what? A whole number in previous two questions. But here I can see that my answer is not a whole number. This means I cannot take these values directly as the simple ratio for carbon, hydrogen and oxygen, and this will not give you the exact empirical formula. Then what you will do in that case? Well, it is quite simple and I have made it very simple for you in the next slide. Can you see in the previous question what we have got? We have got all three as what? A whole number. But in this case, it is not a whole number. So in such cases, you will follow these steps. So first you will check for the situation. So suppose if you have divided the smallest value with all three number of moles and the answer is a whole number, which we were getting in first two questions. So in that case, you will not going to do anything and you will directly write those number as what your empirical formula. But suppose if the numbers that you're getting after carrying out the division are like this, that is, they're very close to the whole number. In that case, can you see it is very close to the whole number? That is 2.99, 5.98, 1.01. They're very close to the whole number. In that case, you will directly round the value. You do not need to do anything. Directly round the value. So you will write this 2.99 as what? 3, and this 5.98 was as what? 6, and 1.01 as what? 1. So you will directly round them. But suppose if the ratio that you are getting after dividing, you are not getting whole number, not even you are getting a decimal number in a way that it is very close to the whole number, in such situations you will follow this method, whatever I'm going to teach. So as you can see, here I have divided, but in the ratio I can see that it is not close to the whole number, not even it is a whole number. So this means I cannot do either this method or this method. In that case, I will follow what? This third method that I'm going to share. So you will not directly round this figure. You are not going to multiply or you're not going to do anything. Firstly, you're going to observe the situation. Based on the situation, if you are landing upon this situation, you will follow this method. So like this question, as you can see here in the question, the ratio that I'm getting as 2.25, okay, and 6.75. I can see that these two numbers are not whole numbers. and not even they are close to whole number. So what I will do, I will directly separate the decimal part, or I will directly look for the decimal part. So I can see that in first number the decimal part is what, 2.25. So I can see that the decimal part is what, 0.25, and in this one the decimal part is what, 0.75. Now you just have to check this particular decimal part with this table, for which one this number is very close to. So I can see that 0.25 and 0.75 matches with this category. So I will look for their fraction, and in their fraction, whatever is the denominator, you're going to multiply with that denominator. So I can see that the denominator is 4. So what I will do, I will multiply these two numbers by 4. So if I multiply these two numbers by 4, they automatically get converted into what, a whole number. So remember these three categories. Is if after division you will end up with a whole number, you can directly write without any problem, without any issue, or without any doubt, you can directly write that number into your empirical formula. But suppose if you have divided and it is very close, it is not a whole number but it is very close to a whole number, so you will directly do the rounding. But suppose if that ratio is not a whole number, not even it is close to a whole number, it is falling into this category. So in that case, you will look for the decimal part, directly check with the table, whatever is the fraction, from that fraction you will choose the denominator and you will multiply those two numbers by the denominator, and you will end up with a whole number. Okay, and then you can use this whole number in order to write your empirical formula. Now let us solve our question. So this is what the data we have got in our question, and I can see that this is not even a whole number, it is not close to a whole number, so this falls in the third category. So what I will do, I will look for the decimal part. So I can see that the decimal part is what, 0.29, and here the decimal part is what, 0.86. Now you have to check these values to with which decimal they are very close to. So I can see that 0.29 is very close to 0.25. So I will write it as what, 0.25. It is very close to. And 0.86 is very close to 0.75. So I will write this value. Now I can check their fractions. I can see that their fraction is 1 upon 4 and 3 upon 4 respectively. I look for the denominator. So here is my denominator, and now directly I'll multiply with the new uh, decimal number that I have got, and I will convert it into what, a proper whole number, and this is what the number we have got. Now I will directly write these numbers, and this is what my empirical formula looks like. Once I have determined my empirical formula, I will directly calculate its empirical formula mass, and once determining its empirical formula mass, I will calculate the value of n using the formula, and from this formula I have calculated value of 1, which is equivalent to what, 1. So if your value of n is exactly equivalent to 1, this means your empirical formula is exactly equivalent to the molecular formula. Suppose if there is some other number, then you are expected to multiply it to the empirical formula. So this is how you're going to solve the question. So in gist you will remember these three things, that there are three categories of questions based on data. If the percentage composition is given, then you will follow these steps to solve the question. If empirical formula and molar mass is given, you will follow these steps. If the combustion analysis data is given, then you will follow these steps. So this is how you're going to solve the questions based on empirical formula and molecular formula. If you have any query, you can mention it in the comment section. I'll be really happy to answer them. With this, we have completed our session. Thank you so much for watching. Do like, share and subscribe to my channel. If you have any specific topic that you want me to teach, you can surely mention it in the comment section. I'll try to make a video on that.